Okay, so what we shall do is, mm, we will choose a matrix such that, okay, already I have told you that a in ax equal to b, the ax what it is doing is, it's doing a linear combination of the columns of the A matrix. So yeah, linear combination of the A matrix. Now let's choose those two columns as a linearly dependent. Okay, let's choose the two columns linearly dependent. So how shall we choose? So this is
2 1 4 2.
Okay. Uh, 4.
2.
Okay. Let's check whether right. Fine. So the first column is
2 1.
is it the first column is okay. Let me once again check what is the first column.
2 comma
2 1 and the second column is
4 2.
4 2, right?
Yes, sir.
Fine. Now what we shall do is, since this is the linear combination of two dependent vectors, okay, now if you drag this point, okay, you cannot reach, this p2 cannot reach all the points in the xy plane, right?
Yes, sir.
So the span of these two vectors, this 2 1 and 4 2, is limited to this line.
Yes.
Okay, it's limited to this line. So which is one of the reason when you try to solve ax is equal to b, okay,
Yes.
if the columns are linearly dependent, okay, then sometimes you cannot have a solution.
Yes, sir.
Okay, so sometimes you may have like a no solution.
No solution.
Okay.
Yes.
Or sometimes you will have infinite solutions, right?
Yes.
So those things are okay. So this is an example for like say for example you want to solve, say come up with p1 such that p2 is uh, say 0 2, sorry, 2 0, which means this point. Okay, now wherever you drag this p1 you cannot reach this particular point. Okay, then such cases, like, it has no solution. Okay, now instead let's choose a point, okay, where the solution is along this point, let's say this point. So I want in ax equal to b, I want b to be 2 comma 1. Okay, now what are all the solution? So if I just drag it, so I'm getting a solution, right?
Yes, sir.
So the solution is 1.78 minus 0.39 something. Okay, now the question is this the only solution?
No, sir.
There will be other solutions.
Yes, sir.
So what is the other solution? Yeah, you can drag and you can. So my output has to be
2 comma
2 comma 1. Right, so that's another solution, okay, which is like a minus 0.46, 0.72. Okay, now if you also notice, so this is the span of the what do you call the vectors of the column vectors of the matrix A. And now let me okay, So I have, so in this case I have infinite solutions. Okay, so that's not the only solution. So now you know that, I mean, generally you might have studied like if the rank is
less than
not, if it's not a full rank, then either the solution will be 0 or infinite. Okay, that depends on the b. Okay, if the b is within the span of that column matrix of A, sorry, the column, yeah, the column vectors of A matrix, then you have infinite solutions. If it's not, if it's out of that span, then you have no solution. Okay. Okay.